Welcome back, everyone. Today, we're diving headfirst into a topic that's absolutely exploding in the world of software engineering, multimodal GPTs.
Yeah, it's pretty wild stuff.
I mean, we've all heard about AI changing how we code, but this takes it to a whole new level.
It really does.
Okay, so imagine this. You're sitting there, sketching out ideas for a new app, and suddenly your AI assistant starts suggesting different layout options, pulling from like a massive library of design patterns and best practices. It's like having a design expert right there with you, but it's all AI.
That's the kind of thing we're going to be talking about today, this fusion of visual design and code generation.
It sounds like something straight out of science fiction, but the latest research shows that it's closer than we think.
Much closer.
And that's exactly what we're going to break down in this deep dive. So whether you're a seasoned developer or just someone who loves keeping up with the cutting edge of tech, buckle up. This is going to be a fascinating ride.
Really?
Now, before we get too deep into the AI side of things, let's talk about something that's already essential to software engineering: diagrams and sketches.
Right, those visual tools we use all the time.
And it turns out those visuals aren't just for brainstorming sessions. They can actually be way more efficient than plain text for communicating complex ideas.
It's true. Think about it. You can often convey an entire concept in a single diagram that would take paragraphs or even pages to describe with words.
It's like that saying, a picture is worth 1,000 words.
Exactly. And there's actually a lot of research to back that up.
Oh, yeah. Tell me more about that.
Well, Edward Tufte, who's like legend in the world of information design, has argued that our brains are wired to process visual information way faster than text. It's just how we're built.
That makes sense. I mean, we're visual creatures, right?
We are. And this research on multimodal GPTs really highlights that point. They looked at something called a class diagram.
Which is like a map of the different objects and relationships in a piece of software, right?
Yeah. Exactly. And they found that when you represent that class diagram using something called plant UML notation, it's a visual language for software, you can make it a whopping 80% shorter than its equivalent in plain English.
80%? That's insane.
It is. And that's just one example of how powerful visual communication can be in software engineering.
So we're already using diagrams and sketches to make our lives easier, but then AI comes along and throws GPT-4 into the mix.
And that's where things get really interesting.
Because GPT-4 isn't just another language model. It can process both text and images.
Which opens up a whole new world of possibilities.
It's like giving AI the ability to not only read code, but also to see it, to understand the visual logic behind it.
Exactly. And that's a complete game changer for software engineering.
I mean, think about it. You could use something like Microsoft Copilot, which is powered by GPT-4, to design a user interface visually.
You could sketch out a rough idea, and Copilot could generate the HTML and CSS code for you, right there on the spot.
And not just that, it could suggest different layouts, color schemes, maybe even pull in design elements from other successful apps.
And all based on your visual input.
That's incredible. It's like having a super-powered design partner that can not only understand your ideas, but can also translate them into working code.
And it goes beyond just turning visuals into code.
Oh, in what way?
GPT-4 can also take existing code and generate visual representations of its structure, things like flowcharts and diagrams.
So you could take, say, a really complex piece of code that's poorly documented, and GPT-4 could create a visual map of how everything works.
It's like giving you an X-ray vision into the code. It could be a lifesaver for anyone who's ever had to decipher someone else's spaghetti code.
It sounds like GPT-4 can basically translate between the visual world of design and the textual world of code, in both directions.
That's a great way to put it. It's like a bridge between these two worlds, and it's already starting to change how we approach software engineering.
And that's just the tip of the iceberg. We haven't even gotten into the specific ways GPT-4 can be used in the different stages of the software development lifecycle.
Oh yeah, we've got a lot more to uncover.
But before we dive into those specifics, I think it's important to understand the different types of modeling that GPT-4 can handle.
Right, because it's not just about turning diagrams into code. It can also handle the dynamic aspects of software.
So let's start with something called static modeling. What exactly is that?
Well, static modeling is all about representing the structure of your software. You know, how the different pieces fit together.
Like blueprints for a building.
Exactly. Think of things like class diagrams.
Right, those diagrams that show the relationships between different objects in a program.
Exactly. And GPT-4 can take those class diagrams and generate the corresponding code in a bunch of different programming languages.
So if I had a UML class diagram for, let's say, a banking app, GPT-4 could generate the equivalent Java or Python code for me.
That's the idea. It takes the visual representation of the software structure and turns it into actual working code.
That's pretty amazing. But you mentioned that GPT-4 can handle more than just static models. What about those dynamic aspects of software?
Right. So static modeling is about the structure, but dynamic modeling is about the behavior of a system over time, how it changes and responds to different inputs.
Okay, I'm intrigued. Can you give me an example of that?
Imagine you have a sequence diagram that shows the different steps involved in, say, a user logging into a website.
The diagram would show the interactions between the user, the web server, the database, all that stuff.
Exactly. And GPT-4 could take that sequence diagram and actually generate the code that implements that specific login sequence, step by step.
So it's not just translating a static diagram into code, it's actually understanding the logic and the flow of how the system is supposed to behave.
Precisely. And here's the really cool part. GPT-4 can also do the reverse.
The reverse. You mean go from code to a dynamic model?
Exactly. Let's say you have a big chunk of code that's poorly documented. You could feed it into GPT-4, and it could generate a sequence diagram that shows you how all the different parts interact over time.
That would be incredibly helpful for understanding how a piece of legacy code works. It's like having GPT-4 create documentation where none existed before.
It really is. And speaking of documentation, that's one of the most exciting potential applications of this technology.
I can see how that would be huge. Software documentation is often outdated or just plain missing, which can be a nightmare for developers.
Imagine a future where AI can automatically generate up-to-date diagrams and documentation straight from the code itself.
The software would basically be self-documenting.
It's a dream for any developer who's ever struggled with bad documentation.
Okay, so we've got sequence diagrams, but what other types of dynamic models can GPT-4 work with?
Well, there are things like communication diagrams, which focus on how different objects interact with each other, and state diagrams, which model the different states an object can be in.
I think I'm getting the hang of this. So if I was building an e-commerce app, I could use GPT-4 to create a state diagram that shows the different states an order can go through, like pending, processing, shipped, delivered, all that.
Exactly. And then GPT-4 could generate the code that handles all those different states and transitions between them.
That's awesome. And I could even use GPT-4 to adjust my code if I needed to change the state diagram later on.
You got it. It's like having an AI partner that can not only write code, but can also visualize and document how it works. And this is just the beginning. There's a whole world of possibilities waiting to be explored.
It's mind-blowing to think about how much AI is changing the game in software engineering. And to think we've only just scratched the surface of what's possible with multimodal GPTs.
There's so much more to come. One of the coolest things they did in this research was use a library system as an example.
Okay, a library system. Got it.
And they start with, a basic class diagram.
To show how it's all structured.
Right, like all the parts, books, borrowers, librarians, all that good stuff.
The blueprint of the software.
Exactly. And then they feed this diagram into GPT-4 and get this, they tell it to write the code.
So they're going straight from a visual representation to actual code. No typing it all out manually.
That's the idea, yeah. Pretty wild, right?
That's insane. But hold on, they didn't stop there, did they?
Nope. They then took that generated code and fed it back into GPT-4.
Okay. Why? What were they trying to do?
They flipped the script, basically.
Yeah.
This time, they asked GPT-4 to create a class diagram, but based on the code it had just generated.
So like reverse engineering it.
Exactly. They wanted to see if GPT-4 truly understood the design, not just the syntax of the code.
Then what happened?
The class diagram GPT-4 made was almost a perfect match to the original one they started with.
Whoa, that's a pretty solid sign that GPT-4 gets it. Like, it's not just copying instructions, it's understanding the design concepts.
Exactly. But, we were talking about dynamic models earlier.
The ones showing how the software behaves, right? Like over time.
Yeah, those sequence diagrams. So the researchers used one of those to map out what happens when a borrower, wants to check out a book.
All those steps involved, like seeing if it's available, updating records.
All of that. And they gave this sequence diagram to GPT-4.
I bet I know what's coming next. GPT-4 wrote the code to make it happen.
You got it. It generated code that followed that borrowing process, step by step, like it was reading a flowchart and writing the instructions at the same time.
That's crazy. It's understanding the logic, not just blindly translating.
And to really drive it home, They had GPT-4 make a communication diagram, too.
What's that? Another type of model.
It focuses on how all those objects in the system, the borrower, the book, the database, how they talk to each other during that checkout process.
So they're using AI to get all these different angles on the same software.
Multiple views, yep, each giving you different insights. But there's more.
More. What else did they try?
Things got even fancier. They modeled those different states. A book can be unavailable, checked out, lost, all that.
Right, and how the code needs to handle each of those.
And they used GPT-4 to adjust code if they change the state diagram, keeping it all consistent.
Like having an AI assistant that not only writes code but keeps it all organized and explains it visually?
Pretty much. But here's the kicker. This tech isn't limited to those formal UML diagrams.
What do you mean?
They show GPT-4 can work with hand-drawn diagrams too.
Wait, seriously? Like, I can doodle my app idea and GPT-4 turns it into code?
That's what the research suggests. Imagine how much easier brainstorming and prototyping could become.
That's a game changer. But amidst all this AI excitement, what about those tried and true design patterns that developers rely on? You know, the best practices for solving common problems.
Great point. They didn't forget about those. Turns out, GPT-4 can weave those design patterns right into the code it generates.
So it's not just writing code, it's writing good code, following established best practices.
And get this, they even suggest AI could help us discover new design patterns as it analyzes more and more code, adding to our toolkit.
That's wild. But with all this AI doing the heavy lifting, where does that leave us, the human developers? Are we out of a job?
That's the big question, isn't it? But the research doesn't point to AI replacing us entirely. Instead, it's more like a partnership forming.
Like AI and humans working together.
Exactly. Think of it this way. AI can handle those boring, repetitive tasks, the stuff that makes us pull our hair out.
Writing the same lines of code over and over, yeah, I get it.
And while AI does that, we humans are freed up to focus on the bigger picture. The design challenges, the creative solutions, the user experience, the ethical considerations.
So AI takes care of the grunt work and we get to do the fun stuff.
You could say that. Plus, remember, these AI models are trained on our code, on all the knowledge we've built up over the years.
So it's like they're learning from us, encapsulating all that expertise.
And making it more accessible. As this tech evolves, we'll have even better AI tools. Tools that not only write code, but analyze it, find bugs, suggest improvements, even learn from how people use the software to make it better over time.
It's like having a superpowered coding buddy, constantly learning and growing with you.
That's a great way to put it. But this goes way beyond just software engineering, doesn't it?
What do you mean?
Think about it. If AI can help us build software better, faster, smarter, what does that mean for all the other fields that rely on software?
Okay, yeah, now you're getting me thinking. Healthcare, education, finance, all of that runs on software these days.
Exactly. What we're seeing in software engineering is a sign of things to come, a preview of how AI will impact pretty much every aspect of our lives.
It's like we're on the verge of something huge, a whole new era of software development.
It really does feel that way.
And you're right, this goes way beyond just lines of code. What are some other fields where you think these AI advancements could have a major impact?
Oh, there's so many. Healthcare's a big one.
Yeah, how do you see AI changing things there?
Imagine AI helping doctors design those personalized treatment plans, based on a patient's genes and medical history.
That's incredible, like truly tailored medicine.
And think about surgery. AI could help there too.
Like robot surgeons or something?
More like AI assisting surgeons, making procedures more precise, less risky.
That could be a game changer, especially for those really complex operations.
Absolutely. But it doesn't stop with healthcare. Education is another field ripe for disruption.
How so?
Imagine AI tutors that can adapt to each student's learning style.
Like figuring out how they learn best and adjusting the lessons.
Exactly. AI could also analyze all that educational data we have and figure out which teaching methods are most effective.
It's like personalized learning on steroids.
Yeah, it could make education more engaging and effective for everyone. And then there's finance.
Oh yeah, AI is already used a lot in finance, right?
For things like fraud detection and trading, but it can go much deeper.
Like how?
AI could analyze market trends, predict economic shifts.
So like helping people make smarter investments.
Exactly. And it could give people more personalized financial advice tailored to their situation.
It's wild to think about all these possibilities. AI really seems to touch everything these days.
It does. But here's the thing. With all this power comes a responsibility.
To make sure it's used for good.
Exactly.
Yeah.
We need to be thoughtful about how we develop and deploy AI make sure it benefits everyone.
It's a lot to consider. So, as we wrap up this deep dive, what's the one key takeaway you want our listeners to remember?
That the future is being coded right now, and AI is a huge part of that.
It's happening whether we're ready or not, right?
It is. And it's not just about techies. It affects all of us.
So, everyone needs to pay attention, educate themselves, and be part of the conversation.
Absolutely. It's our future we're shaping here.
Well said. Thank you so much for joining us on this deep dive. It's been an incredible journey exploring the world of AI and software engineering.
It's been my pleasure.
And to our listeners, keep exploring, keep asking questions, and keep learning because the future is coming and it's powered by AI. Until next time.